So what I would like to talk about today is applying the binomial theorem. As we go through this PowerPoint slide, I will not go through the entire PowerPoint slide. I will go over it to get you started. I have loaded it for you to review, but I want you to understand what the binomial theorem is. I'd like you to understand what Pascal's triangle is, and I would like you to be able to use Pascal's, okay? So, right now, when you multiply these things, you remember that you have to multiply them using the distributive property. By distributive property, I'm basically distributing the first term with the first term over here, the first term with the second term over here, the second term with the first term, and the second term with the second term. And I'm distributing. Some of you learned this as FOIL. It depends who your teacher was, whether they taught you the distributive property of FOIL, but you learn different ways. So when we expand this one, similar to what we did on the bell ringer, you would multiply them both out and then distribute them. This is what we call the perfect square trinomial. You learned that during the polynomial identity exercise. Now, when you get to the larger ones, this is a good example, x plus 2 to the cubed power. This can get a little more difficult because I want you to look what you have to do. What you have to do is go through a process where you multiply two of the terms and then you distribute the third term. And this can get a little bit complicated as that gets higher. You're also likely to make a mistake if you're not careful. So as we go through here and expand it, we're going to learn what we call the shortcut. Because look here, when you have the fourth and the fifth and the sixth power, this can get more tedious and more challenging. Okay? Now, I don't want you to overwhelm yourself when you see this big screen here. When you see this big screen. So the binomial theorem, or expansion as we call it, is a quicker approach to expand binomials. In other words, we're multiplying them out in a shortcut method. There's a lot of annotation here you may not understand, and that's okay. I'm going to work through an example with you to kind of give you an idea. But that is the formula. I don't want you to memorize that formula. Matter of fact, I don't want you to try that formula. It's a very difficult one to see what's going on. But I'm going to work through an example using that formula. So if I use that formula, what I have to do is I have to start off. Let me annotate here. Let me get my pen out. I have to start out with, this is the highest exponent right here. You see n equals 3. That's where I'm starting with. Okay, so k equals 0. That's starting with 0 going to 3. 3 factorial. You go through the formula. X to the 3 minus 0, 2 to the 0. 3 factorial, 3 minus 1. So this is a process we go through. And you end up getting this answer right here. This is how a calculator does it. They use it, the theorem. They use things to do that. So, here are my drawings here. Quit annotating. Now let's go to the next slide. Now, the binomial theorem is a quicker approach without direct multiplication, but you're going to use what's known as Pascal's triangle. You're going to use what's known as Pascal's triangle in order to do that. Once again, you're not trying to memorize anything because you'll see it's relatively easy. Let's go through it using Pascal's triangle. So when I use Pascal's triangle, I start off with 1. I write 1 and 1 on each side, and then I add terms. The 1 stays on the outside. 1 plus 1 gives me 2. Leave my 1. 1's on the outside. 1 plus 2 gives me 3. 2 plus 1 gives me 3. Bring the 1 down. Keep with the 1 coming down. 1 plus 3 gives me 4. 3 plus 3 gives me 6. 3 plus 1 gives me 4. And bring down the 1. Bring down the 1. 1 plus 4 gives me 5. 4 plus 6 gives me 10. 6 plus 4 gives me 10. 4 plus 1 gives me 5. And this goes on and on and on. So what you're going to learn is this is raising it, like for example, x plus y all squared. X plus y all cubed. X plus y to the 4th. X plus y to the 5th. Now, on the top one here, I'll go ahead and write for simplicity, x plus y to the 1st power. And what I want you to know is the row that I'm referring to is based upon this exponent. And if you look right here, these are your exponents. Those are your exponents right here. So you can see how I've got it lined up. There's with the 1, that's with the 2, that's with the 3, that's with the 4, and that's with the 5. So it depends what expansion you're raising it to. But that becomes the row. So when I ask you what is the row when you're raising something to the 3rd power, those are your coefficients. 1, 3, 3, 1. If I say something to the 5th power, your coefficients are 1, 5, 10, 10, 5, 1. That's what you're multiplying it by, and that's how you determine the coefficients. So we're going to practice this. I'm just trying to use a little bit of time to do some instruction. Let's quit annotating. Let's go to the next slide. And let's look at an example. Now I'm going to go through this, and it may seem a little fast, but as I go through it, then you're going to have an opportunity to go through it on your own because I've loaded these slides. So let's look. Here's the example using binomial theorem and Pascal's triangle to expand x plus y to the cube. Okay. First, I pick the row for Pascal's numbers. This was a 3rd, so the numbers are 1, 3, 3, 1. 1, 3, 3, 1. Next, I take the first term, x, 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 and do decreasing exponent, 3, 2, 1, 0. I started with a 3, 3, 2, 1, 0. Next, I put the second term in there, and I do backwards exponents. Y to the 0, y to the 1st, y to the 2nd, y to the 3rd. All I'm going is backwards. And if it helps you realize, 3 plus 0 is 3, 2 plus 1 is 3, 1 plus 2 is 3, 0 plus 3 is 3. This is how you will set up these examples. So this is an important slide to see. And like I said, I've loaded these for you and it's learning. And the final answer, you can see what I did. Annotate. All I took is anything to the 0 power is 1. 1 times 1 is 1, x cubed. That's how I got the x cubed. Y to the 1st power, x squared and 3. That's how I got the second term. 3 times x to the 1st, y squared. 1, x to the 0 is 1, y cubed. So these are how we are expanding these. Now make sure, whatever this term is, you're putting it. So in this case, what if it was 2x? Then all these where you see x would be 2x. And let's say if this y was 5, then everywhere you see a 5 would be a y. So that's kind of how we're doing it. Okay, so now on a scratch sheet of paper in front of you. We're going to walk through this together. I recommend you taking a scratch sheet and working it through with me so we can do it together. So let's walk through this. Okay, I'm going to get my handy dandy pen out. And over here in the side, I'm going to quick light write Pascal's numbers for you. So here's 1, here's 1, 1, here's 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Now, we start here. This is a 3. So this is the row I'm looking at. See, there's my 3. 1, 2, 3, 4. So this is a row. So you first write Pascal's numbers down. So here's my 1. Here's my 3. Here's my 3. And here's my 1. Okay? Now, step 1. Determine Pascal's coefficients when we start this. Now, let's look at step 2. Step 2 is I want to look at my first term, which in this case happens to be x. See the x right there? So I'm going to take the x and put it in each one of those as my first term. There's my x's. They're all in the first term. I'm going to take my highest exponent, 3. I'm going to count down 3, 2, 1, 0. Now, so I've got Pascal's numbers, 1, 3, 3, 1. I have my first term, x, 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 x. And I have my exponent, 3, 2, 1, 0. Now I go to my second term, second term, second term, second term, and second term. And all I do is put the 2 in there. 2, 2, 2, and 2. And now I go backwards. So instead of 3, I start with 0. 0, 1, 2, and 3. Okay. So now I put a plus. Now let's pause just for a quick second. I want you to see if this was a x minus 2, all these would be negative 2. If this was a negative 3x, all of these values would be negative 3x. So you put whatever's in there for that term. This is called term 1, and this is called term 2. Okay? And this is Pascal's. Now let's multiply it out and see what we get. Well, 2 to the 0 is 1. 1 times 1 is 1, so this is just x cubed. 2 to the first is 2. 2 times 3 is 6x squared. 2 squared is 4. 4 times 3 is 12x. And 2 cubed is 8. 8 times 1 is 8. X is 0 is 1, so this is plus 8. And that becomes your answer, x cubed plus 6x squared plus 12x plus 8. So this is how we use the binomial theorem and extend Pascal's numbers to help us with the coefficients when we work these.